Chemistry Lab 1 Introduction of Laboratory Equipment. So the first one I will talk about the mass measurement because when you come to the lab you may need to measure the mass of your chemical or maybe some object for your reaction or maybe for some purpose in the lab. So the first one I consider about the digital balance. So you come to the lab you may see some kind of the digital balance like this and you use this kind of device to measure the mass, maybe for some object, maybe the clean bottle, or you may need to measure the mass of the chemical for your reaction. And when we consider about the digital balance, so how to choose the balance for your using, because you come to the lab you may have this kind of the balance. So which one will you choose? The first one you should consider about the mass of the object or chemical you want to use, because each balance we have the minimum mass and the maximum mass. If your mass is lower or higher than this range, and then you cannot use for your measurement. That is the first one. And the second one, it depends on how much you have and the unit you have for your balance. Because in the balance, you may want to measure for the milligram, maybe for gram, or maybe for kilogram as well. So different balance, we may check about the unit we have from here. So if we don't have that kind of unit, so it's really difficult for us to make the measurement. Or you can change to another unit for your balance as well. Okay. And the next one, when we consider to choose the mass, you need to consider about the resistance as well. So from here, you can see I have 1.0 gram, 1.00 gram, 1.0000 gram. So you see the different number for our significant figures as well. So it depends on your measurement and you can choose the different for the balance. So you can see from maybe I consider about this one and this one. So from here, you see for our value for measurement here, you have only two number behind the decimal points. But for this one, we have four number behind decimal point. So if I ask you to weight 1.00 gram, so you can use this balance or this balance, no problem. Because for this one, you can get 1.00, okay, and this one you can get 1.00 and the last number maybe 00 or maybe 01, or even you get this one 1119 something. It's okay, no problem, because our significant figure only until here, so only three significant figure only. Okay, but if I ask you to measure 1.000 gram, and then you should use this one. Okay, we cannot use this one because you use this one. This means that you have only two zero behind decimal point. So it depends on the precision of your experiment for your reaction, and you should choose the correct balance for your measurement. Okay, and in here we call this one is the analytical balance. So we can use to measure the mass of our chemical or the substance with four number behind the decimal point. Okay, and the next one you also can see from here. For this balance, we have air around the balance. But for this balance, actually also air, but we have the window to close our balance. So it means that for this one, if you turn on the fan in the lab, and it may affect to your result. So remember, for the balance, we usually turn off the fan on no wind around our balance. So for this one, if you put the object here, so maybe the wind come and it can affect to your result. So the number here will continuously change. But for this kind of balance, we can close the window here, the door here. So it means that everything inside will be the static condition, so then you can get the result better. And when you make the measurement, if you have the number here keep moving, so it means that you have something affect to your measurement. So you should check whether you haven't closed the window, the door here, or you have something moving inside your measurement. Okay. And also another thing really important, that one is the balance. Usually you come to the lab and the balance already as balance. Balance is mean that whether we have the position here for our balance the same or maybe different, maybe one position higher or maybe one position lower. So it means that it's also affect to your balance. So how to check the balance before measurement? So you all can see from here, I make the circle here, the circle here, and the circle here. So each balance we have one place, and in this place you can see something like this. You have the circle and we have one purple. If the purple inside the circle, it means that your balance is as the balance condition. It means that for different position here, the same for the height. So it's okay for your measurement. But if you check the balance and the bubbles here move to outside, so it means that one position may be higher or lower. So if you make the measurement, the results will be not good. Okay. So you should consider about the balance for your measurement, and also you also need to check about the purple here for the balance. Okay. And the next one, how to use the digital balance. So for any device, right? For electronic device. So if you want to use, you need to turn it on. Okay. So we have the bottom here, so you need to turn it on. Okay, and you may come to the lab and everyone use the balance, so the TA may turn it on already, so you don't need to do this. And during the class, so you shouldn't turn off the balance, just keep there because maybe someone want to use the balance. So when everyone finish, and then we can turn off, because if you turn on, turn off, turn on, turn off, and then your balance will be unstable and not good for your measurement. Okay. And also the second one, we should check about the unit. So you may have the unit here, or maybe in some balance we have maybe the mode, or maybe some different for the name here. But when you press here, and it may change to kilogram, or maybe it can change become gram, or it may can change become milligram. It depends on the balance you have. Okay. And for this one we have unit here, but maybe for some balance we don't have the unit here, we may have the mode. It depends on the balance, you can check it. Okay. And you can see from here, for some balance, they can connect with the printer, and you also can print the result. But in the lab, we don't have the printer because you need to record everything by yourselves. Okay. When you work in the company may provide the printer, and when you make the measurement, and then you can print the result to make the report. Okay. And the next one, because when you make the measurement, when you turn on, or maybe someone use already and you check the number here, maybe not at 0.0000, okay? So it means that maybe it has some value, maybe 0.050, or maybe 0.009, something like this, okay? And before the measurement, you need to press this bottom, tear, okay? When you press tear, so it means that your balance will move back to 0.000, look like this number for your measurement. Okay, or maybe in some condition you want to use the container to put the chemical on the container for your measurement. You cannot put the chemical directly to our balance because you cannot clean it, you cannot take the chemical as well. Okay, and also not good for the balance as well. Okay, so how to use? You may use some container. If I put one container here, and then I add the chemical, right? But I just want to measure the mass of the chemical only. So what should I do? So because when I put the container, so I have the mass, maybe the value here, it can change to some value. So I need to press this one, tear. And when I press this one, tear, so it means that we have the container here, but all of the number here will change become 0. Okay, and then I add the chemical, and I read the value here will be the mass of the chemical only, because we make the mass of container become 0 already. Okay, so when we get the value, maybe you get 1.234 kilogram. Okay, for this measurement, and then when you take it out, and then the balance will change become minus 1.234 kilogram. So you see the next people come and can see this value. So before you make the measurement, you need to press this bottom again, and then you can start to measure the mass of your chemical or your object as well. Okay, and the next one, how to weight the object or maybe the chemical. So for object, so you check, and if the mass of the object is less than the maximum mass of the balance and higher than the minimum mass of the balance can use. Okay, and then you just directly put to the balance and you read the result. Okay, and from here, before you start your measurement, and then you should remove everything, nothing inside at the beginning, nothing inside, and then you press tear and make everything become 0, and then you open the door here. And remember, before putting your object, you also need to close the window, the door here, and then you press tear tar, it will become 0 0 0 something, and then you will open the window and put the object inside, and then you close the window, and then you can read the result from here. And you need to wait until it get the stable number. If it keep moving, you should check whether you haven't closed the door here, or maybe something affect to your results. So because we have one door here, and one door here also, so maybe you forgot this door also can affect your result. Okay, so for the object, it's very simple. But how about for chemical? Chemical, you cannot put directly on the balance because I already mentioned, right? Not good, okay? So you need to use maybe the weight bolt, or maybe you use the weight paper for your measurement. So you put the weight bolt or the weight paper at the into the balance, and then you close the door, okay? And then inside at the beginning you have only the bolt, or maybe for the paper only, and then you press tar, and then everything becomes 0 here. It means that we don't count the mass of this one and this one. And then you can add the chemical to our balance. You open the window, and then you add the chemical, and then you close the window again. And after you close the window, and then you can see if you get the stable number here, and that one will be the mass of the chemical only. So that's one is the methods we can make the measurement. Okay, and in the left, if we provide this, you can use this, but usually we can use the paper for your measurement. Okay, or maybe in some condition you want to prepare for the chemical, maybe in some container, and if you have the container, maybe the bottle, or maybe you have the beaker, and you because you if you want to dissolve the chemical, right, maybe you have the beaker, so look like this beaker, the small beaker, and you want to dissolve the chemical into this beaker, you also can consider to use this one as the container for your measurement. You don't need to use the weight the weight paper. Okay, so it means that you can if the mass of the beaker here is less than the maximum mass, because we consider about maximum mass of the balance, you can use. If it's less than that mass, and then you can put the beaker inside, and then you press task, and later it will become 0. It means that we don't count the mass here, and then you add the chemical, and then you can get the real mass for the chemical, and you record that one. Okay, and if you use the weighing paper, and the weighing paper, if you don't fold your weighing paper, and after you finish, and maybe difficult for you to take the chemical from the weighing paper to some container. Okay, because for the big container very simple, but maybe you have some bottle. Okay, the bottle may be something like this, and you have very small neck, and then difficult for you to put the chemical inside. Okay, so you need to fold your weighing paper with 3 lines as I draw here. Okay, so 1 2 3, you make the line this like this, and then after you put the chemical inside, and then you can keep this position and this position with your finger, and then all of the chemical stay inside, and then you can add this position, and the chemical just come to here, and easy for you to put into the small neck for the bottle. Okay, and the next one, after using, you should clean the balance, because if you don't clean the balance, it will be really dirty, and it may affect to the result of the other people. So if you use the balance and it's really clean, and it's okay, you don't need to do anything. But when you add the chemical, some chemical uh, maybe go out, not inside the container, so you need to clean the balance. And also remember, if you put the container, maybe the container like this, right, and you make it become 0 already, and then you try to add some chemical inside, but not all chemical inside, you have some chemical go out like this, and then you need to repeat again, because you see from here the mass here will be the chemical inside and chemical outside. You cannot collect the chemical outside for your experiment. So when you make the measurement, it look like very simple, but you may have some mistake, maybe some error in your result. Okay, it depends on the skill you have. Okay, and the next one we consider about the volume measurement. Volume measurement is mean that we want to know about the volume of our solution. Usually in chemistry, we will consider about the volume of our solution, okay? So we want to know the volume. So volume may be in milliliter or maybe in liter, okay? It depends on the experiment you want to use, but usually we will use in milliliter, okay? Not much for the solution. So we may use the beaker, we may use the volumetric flask, we may use the pipette, we may use the burette, or we may use the radioactive cylinder. I will tell you what we use and how to use, okay? And you should check it carefully, and when you come to the lab, you should know which one can be used and which one cannot be used for some purpose, different purpose, okay? And how to read the result, okay? And the first one I consider about the beaker. So beaker, this one is the beaker. So you come to the lab, you see something like this, and you know the name, right? Beaker, okay? If I ask you to give me the beaker, you should know this one to give me. Don't give me the bottle or maybe some other thing, okay? And the beaker, we usually use to store the solution or maybe the waste solution after your experiment. You can put into the beaker, okay? And from here, you also can see some level in your beaker. You also can see the total volume you can put into this beaker. Why this you have this number? Because maybe you want to keep 500 milliliters, so you cannot put into this one. So we need to check this one for your using, right? That's the first one. And the second one, we have some level here. Why we have the level here? We don't use the beaker to measure the volume of the solution for your experiment, okay? Because the the beaker will provide really low accurate value, okay? So from here they give you the number from here just for your preference. It means that if you want to do experiment maybe around 200 milliliter, so you just fill the chemical maybe around here. No need to fill too much, you will weigh your chemical, okay? Or maybe you want to use for 300, so we may to fill chemical until here. So this one just want to know around value for the volume you have for the chemical inside you have only, okay? So don't use this one for the measurement of the volume for your experiment, okay? So from here you can see we use the beaker to estimate the volume. It means that you may have the experiment and you may need 250 milliliter, so you can consider to add the solution until here only, and then you can finish all of the solution in your experiment. Don't put too much, okay? And I already mentioned, right? You don't use this one to measure the volume because really low accuracy, okay? Because the surface area very large and difficult for you to read the value from here. So maybe a little bit lower, a little bit higher, and the value already changed a lot, okay? And from here you also can see we have 400, right? But maybe in the beaker they only give you the scale here, the level here only until 300 only, okay? So maybe the level here 300. So when you add the chemical, this one is 50, 100, 150, 200, 250, and 300. So when you use the chemical, maybe chemical come to here and you know, oh, you have 150 milliliter in your beaker, okay? Or maybe in some other purpose, if you have the chemical like this at the beginning and then you want to add around 100 milliliter to another container, so you can see we need to add until here, from here to here will be 100. So that's the reason why they have the level here and they also have another level here, okay? And similar, this one just a smaller. So in the lab, we may have many kind of beaker, maybe 50 milliliter, maybe 100 milliliter, 250, and we may have 500 milliliter, or maybe even you also have 1000 milliliter, okay? And remember, beaker not for the measurement of the volume in your experiment, only used to store the solution, the liquid, and the waste solution only, okay? And the next one, we consider about the radioactive cylinder, and here we only have radioactive cylinder. We don't have under radioactive cylinder, okay? You are under radioactive cylinder, but we don't have under radioactive cylinder, only radioactive cylinder only. And we use this one to measure the volume and it will be more accurate, okay? And from here you can see in our device, the tool, the radioactive cylinder, you can see they may provide you maybe the value for the total volume we have, but because the figure here they may not put the number in here, but you can see the maximum one, 25. And you also can check the unit. So you see from here we have 25 milliliter. This one is the maximum volume of the cylinder we can use. Okay, and from here they also make it become level. So you can see this one is 5, this one is 10, 15, 20, and 25. So you're already studying chemistry, right? The unit is really important. So you should check the unit in your device to make sure that's in milliliter, or maybe some device they will write liter, so you should know the number here will be liter. So in the level number here, they will give you only the number only, the value only, no unit, and you need to check the unit in somewhere here. Okay, and after you get this one, and you see you can make the measurement for our volume, because the processional error very small, and then you can read the value. Okay, and from here you can see it depends on the device as well also. So if you have level here 5, this one is 10, so you can check the level inside, right? So 5 is mean that you have one level in the middle, 2 level, 3 level, 4 level. So it means that this one will be, this one at the beginning we have 5 here, right? And this one will be 6, this one will be 7, this one will be 8, and this one will be 9. And here we have one more in the middle. So it means that you can measure look like 5 or 5.5 or maybe 6 or maybe 6.5. So this one we can make it become 0 also. Okay, so in the middle here you also can consider this one will be, the value will be 5.75, right? Okay, in the middle as well. So it depends on how many level they make in your device, and you can use it to read the value as well. Okay, and how to read it, and I already mentioned in chemistry, right? And you can see from here, you move your eyes at the same level with the meniscus. Okay, so for meniscus here, because the meniscus is mean that this position you read, and you need to move your eyes to this the same level, because the same level is mean that you read the value here. If you put your eye here, so it means that you read the value lower. You put your eyes here, you may read the higher value. So remember to put your eyes at this position. Okay, and then you can read the value. Okay, so from here you can see not only one level, any level in your radioactive cylinder, you also can know the volume. Okay, so from here you can see this one is 60, right? And this one will be 70, and you should know how about the smaller level. So this one we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that you have 60 here, so every level will be 61, 62, 63, 64, and so on. Okay, and then when you read the value here, so the position of the curve here, okay, will be this level. So you see 60, 61, 2, 3, 4, 5, 6, 7. So this one will be 67 milliliter. Okay, or if the level in the middle, right, maybe in the middle a little bit higher until here, so we can get 67.5 milliliter, because the next one will be 68 milliliter. So it depends on the level you have and the position of the liquid, and then you can get the value for your measurement. Okay, it looks simple, but you may confuse for the first time of using, so you should check it carefully. Okay, and memorize how to use this. Okay, and when you read, and I already mentioned, right, how to read the value, and remember no purple in the radioactive cylinder, because if you add the solution inside, I don't know what you do, but you have some purple here, some air here. If you have air here, it means that air also have the volume, so the volume here, not the volume for your solution. Okay, so I already mentioned to you, right? I just want to make the conclusion here for the radioactive cylinder. So you need to know how to read the value. So you should check the number you have, and the level in the middle, and you will know how much for each level, and then you can calculate. Okay, and you remember, if you have look like the level, this one is level 6, this one is level 7, only 2 level like this, and our liquid level will be in the middle. So you may reach 6.5, it's okay. Or maybe a little bit higher, you have 6.7, it's okay. A little bit lower, you have 6.3, it's okay, no problem. But you cannot read look like 6.51 something, because you cannot know the last number from here. We studied the significant figure already in chemistry, so you should know how to read the value and to give the number in your report. Okay. And the next one we consider about the volumetric flask. So what is it? That is the one we can use to measure the accurate volume. Okay, we can get the better result. Okay, but from here you can see we have different size of the flask. We may have maybe 10 milliliter, 25, and so on until 500 milliliter. So it depends on the solution you want, how much of the solution you want to prepare, and you can choose the different for the flask. Okay, and from here, for this kind of flask, we don't have the liquid level, because the liquid level here, if you have many liquid level, and it will not accurate. So from here, the most of the solution will be stay here, and we make it become smaller surface area here, and then we can read the value easier, and they have one level. So you can see each flask we have only one level. It means that if you add the solution until this level, and you can get this volume until this level, you can get this volume, and so on. Only one value for our volume only. We don't have many level. So you can see this one may be the plastic material, or maybe the glass material with the transparent one, or maybe with the dark color, because maybe some chemical is really sensitive with the light, so we need to prepare in the dark one to protect our chemical. Okay, and from here you see each volumetric class can be used to measure an amount of the volume. Example, we use this one, we only know 500 milliliter. We cannot know how much for 100 milliliter for this kind of device. Okay, and how to measure for 400? So maybe 500 you add at the beginning, you get this, right? And you have one more, maybe 100, and then you add 100 from here to here, and then the rest one will be 400. Okay, but this one usually we don't use that way, but maybe in the lab we don't have 400 one, and we can do that way. Okay, but actually this one we don't use to measure the volume of the liquid, because usually if we use for the liquid, or maybe we use for the solution, right, then we can use the radioactive cylinder. Okay, so for this kind of device, usually we will use for the reparation of the chemical, because when we repair the chemical, we may use the powder, or we may use some liquid something, and then we want to dissolve in some solvent, because we may consider about the concentration, and concentration later you will study in chemistry. Okay, and concentration usually we use the molar concentration. Molar concentration, maybe we prepare the solution CuSO4, maybe we prepare 0.1 molar, so it means that we have 0.1 mole in 1 liter, and this liter will be of the solution. Okay, it means that in total. And if you don't use this one, and you just look like you know the mole number, right, and then you can calculate for the mass of the substance if you know the mass of the solid already, and then you can wait, you make the measurement for the mass with the balance you know already, right, and then you want to dissolve, and this one you want to get 1 liter of the solution. If you just use the some device, maybe this one to measure for the liquid only, the solvent only, maybe the water only, or maybe you use the radioactive cylinder to measure 1 liter of the water only. But actually when this one and you disturb the chemical here to 1 liter of the solvent, you may get more than 1 liter of the solution. So usually when we repair the chemical solution, we use the volumetric flask to repair it. How to repair? So the first one, you know the mass of the chemical, right? Maybe I consider about CuSO4. I know the mass of the chemical. I make the measurement for the mass of the chemical, and then I add the chemical into this bottle. And when I put into this flask, and the chemical will be here, okay? And then I will add solvent. I use water as the solvent, and I prepare 500 milliliters. So I already calculate at the beginning. So how much of the mass of this chemical in 500 milliliter I can get maybe this concentration. Okay, and then I need to fill until this level. I want to get 500 milliliter, because 500 milliliter will be the volume of the solution, not solvent. So it means that the total volume, because you know that maybe the volume of CuSO4 not much, but also has some value in the volume in our solution. Okay, so you have the chemical inside, so you may add some water, maybe the water until here. Okay, and then you close the flask, and then you can shake it, or you can inverse up down. You can look like this one is the cap, right, and this one may be the bottom. So you can keep like this, and then you keep the bottle like this, because you already close the cap carefully, and then the water cannot go out. So you can move it up down, you shake it inverse the flask, and then you can see the chemical inside completely dissolved. After completely dissolved, so you can see maybe the solution until here, right? But we need 500 milliliter, and then you add more water, and you can add water until this level. And remember, when you add the water from here to here or to here, you can use the beaker, or maybe for the water bottle is okay, you can add water easy. But when the liquid until here already, the level until here already, and when you want to add more water, you cannot add by using the beaker, because if you use the beaker, maybe you add the water over this level. Over this level, it means that everything is incorrect. You need to make the reparation again. Okay, so only until here, because over than 500 milliliters, so it means that the concentration already changed. Okay, and we don't know how much different from here, we also cannot calculate. Okay, so how to add the solution from here to here? You need to use the proper. So what's the proper? I will show you later. This means that you just add drop by drop, and then you can get this level, make it accurate. Okay, and from here I already mentioned, right? So we prepare the solution, and you add the chemical, and you add some water to dissolve the chemical by shaking up down, right? Or you can inverse the flask, and then you add the bottle, reach the level. And the volume we have here will be the volume of the solution, not only for the solvent, not only for water only, also including the volume of the maybe the chemical, maybe the powder, or maybe something. Okay. And the next one we'll consider about the pipette. Okay, so pipette we will use to measure the aqueous volume. Okay, so actually this one is just for my number, not the standard one. Okay, so my number here, I just want to show that some equipment or some apparatus, and we cannot make the exactly measurement or accurate measurement, and maybe we have something can measure with the higher accurate. Okay, and from here we can see that this one is the pipette. If you come to the lab, you should know this is the pipette. Okay, so now you already know, right? So when you come to the lab and I said that you use the pipette, something you should know is okay. So we may have two, actually maybe a little bit different. Okay, but we may have two main pipette we have here. The first one, you can see the total volume, and you also have the level. Okay, and the second one, we have only one value only. Okay, so for this one, maybe this one 100 milliliter. Okay, so it means that you only can use this one to take 100 milliliter of the water only. Okay, but for this one, we may have this one maybe 5 milliliter, but you also can make the measurement maybe 4 milliliter, no problem. 2 or 3 something, you also can do that. Okay, or even you have 4.5 or maybe 0.1 something, you also can see the difference in the level from here. So it depends on the pipette you have. So if you use this one, you only can take one value for the volume, but you use this one, you can have many value. It depends on the scale, the level of your pipette. Okay, and for this pipette, how can we take the chemical into this pipette? Because we already mentioned about the beaker, right? So beaker very simple, look like this, look like a cup, right? This is the beaker, and you just use the bottle and add the solution, maybe the chemical, directly to your beaker. Okay, and if you have the brachiatic cylinder, something like this. Okay, and then you just use the beaker, or maybe you use the bottle to add to here, but I suggest you to use the beaker to add the chemical into this one, because the beaker is mean that you have the large rotational error, easy for you to add the chemical from the bottle, but this one very small, it's not easy. So you add to here, and you can add from here to here, very easy. Okay, and then how about for the pipette? And from the pipette here, we cannot add the chemical by this way, or we also cannot add the chemical, because here I put something on the top already, because we have the hole here. Now at the top we have the hole, we cannot add the chemical by this position, or we also cannot add the chemical by this position. If you remove this one, we also cannot add this. Okay, and how to add the chemical? So for pipette, we need to use another thing, and we call that one is the pipette filler proper. Okay, so this one is the pipette filler proper. We have different shape. Okay, so for this one, it means that we make from the proper, and then we can fill the pipette. So we call that one is the pipette filler proper. Okay, and we can use this one to draw the liquid into the pipette. Okay, and how to draw it? And the first one, you should remove air inside the pipette filler proper. Okay, so because you have air inside, air inside here, air inside here, air inside here, right? So you remove air, and then you connect this one into the pipette at the top of the pipette. So at this position, you cannot connect to here, right? Okay, so you connect this one into here. Okay, and then you can slowly let the air move up, because you know that inside, if you don't have air and air in the pipette, because this one you can put into the container, maybe I have the solution inside, right? So when you let the air move up, fill to this proper, so it means that air here move up and the liquid can move up. Okay, and when the liquid move up, remember to make it carefully. Don't let the liquid reach the pipette filler proper, because if the liquid come to here, it means that it's really dirty and dangerous. Okay, and difficult for you to clean it, and also dangerous if you use for the acid or maybe some toxic chemical. Okay, so remember, just take the solution until maybe the level you have here, maybe 5. You just take a little bit higher only. Don't let it come very close to the pipette filler proper here. Okay, or maybe for this one you can see the level here, so just let the liquid come until here only. Why we want to let the liquid come higher than the level? Because later we will remove this one, and you use your finger, we use index finger to close this hole, and when you close this hole, it means that the liquid can be stay inside. If you don't close this one, so it means that air can go down and liquid can move out. Okay, because you close this and you can control the liquid level inside. Okay, so from here, if you have this one and then you have the level here, right? And then you may, at the beginning, you may draw the liquid until here. And then you use the index finger to close this one, okay? And after you close this, and you maybe at the beginning when you remove the proper here, so maybe the liquid go down a little bit until here, okay? And with the finger, and you can open slowly. You open a little bit, you let a little bit air move inside, and then the liquid can move down, and liquid move down, and you can control until the liquid come to this level. And you know that inside the pipette here you have 100 milliliter. And similar, if you have this one only 5 milliliter, so it means that at the beginning here, and then when you remove the proper, and then you use the finger to keep the liquid level, maybe it can move until here, because when you remove the proper and you put the finger, but not immediately, right? So maybe a little bit go down, and then when the liquid go down here, and you can let air come inside slowly, and then you can control the liquid level until here. Just mean that inside your pipette you have 5 milliliter already. Okay, so you have 5 milliliter or 100 milliliter, and then you can add this one into the container. Okay, when you add to container, it means that the amount of liquid here will be 100 milliliter or 5 milliliter, and you use this one if you control well and until the liquid come to here. So it means that from number 5 to number 4, so it means that you already add 1 milliliter of the liquid into your container, and maybe come to here you already add 2 milliliter, come to here 3 milliliter, and so on. Okay, so for this one you can add the volume of the liquid with the different value for the number you have from here, but for this kind of the pipette you have only one value only. Okay, but when you use this one, we may have some problem. Example, when you remove air from the pipette filler proper, and then not enough air for you to draw the liquid. Maybe the liquid just come until here, and then no air inside. But you know no air inside, so it means that you cannot continue to draw the liquid, because no air, air cannot move up, and then liquid cannot move up. Okay, so for this problem, and then you will take the rubber out, this one out, and then you use the finger to close the hole here, and then you press this one again to remove air inside again, and then you connect to here again. Okay, and then you make it slowly for the liquid move up. And remember, when you let the air move up and draw the liquid go up, just just make it slowly. Okay, don't make it so fast, because if you make it so fast, it means that the liquid directly go up like this, and then it can come to the pipette filler proper also. Okay, so that's the technique I show you. And for the pipette filler proper, we may have some kind of pipette filler proper, and you come to the lab, you may see this one or this one, because this one we sell them because this one too small. We may use for some small pipette only, but usually we use some pipette like this. We may have this one and this one, or sometimes you also have this one. So what's the difference? Okay, so for this one, we have only one position here to remove air or let air coming and liquid can go up. Okay, so this one, every time when you use air, you should carefully to control about air. Okay, but for this one will be more convenient. So what's the convenient here? So you can see this one you connect to the pipette, and this one only air, this one only air. Okay, so you should connect this pipette filler proper to the pipette like this way. Okay, and when you make the connection like this, and you can see if you let air move up, and then you can draw the liquid up. Okay, and from here they have the valve here. The valve here is mean that they also lock here, lock here, lock here. Okay, so when you lock here, lock here, lock here, so it's mean that air cannot go up. Okay, and then you can press at this position. When you press this position, and it will open, and then you press this position, remove air out. Okay, and when you remove air out, and inside no air. Okay, inside no air, and you can see you can rest here again slowly. You rest here slowly, it means that you let the air fill in here, and then the liquid can move up. Okay, and when you want to release the solution, something like that, you also can rest here, because air can come here and go down here, and then the liquid level can go down. Maybe at the beginning you come to here, right? So for this one, you don't need to take it out. It's okay. So you just make the connection for this one to here already, right? So you have one air here, one air here. So at the beginning, you remove air by using this position, and then air move up. So maybe your liquid come to here, right? And then you just slowly release air here, release air here. So it means that air can move inside, right? No, not release air. It means that air here can come inside, and then let the liquid move down slowly. And move down slowly, you can control the liquid level like this. Okay, and for the pipette, we have some steps like this. The first one, we will use the pipette filler proper to draw the liquid into the pipette. Okay, so you see, I mentioned, right? You remove air and connect to the pipette, and then let the pipette connect the tip of the pipette. You put into the container with the liquid inside, right? And then you let the air move up, so liquid can move up and higher than the level you have a little bit. Okay, and then you remove this one, and you use the index finger to keep here, and the liquid here, and then you just let air come slowly, and then come to the level you want to control. Okay, and for this one, remember, when you use this one, and before adding the solution here into another container, you should clean the liquid outside of the tip, because you have the pipette. Maybe I repair the pipette, right? Maybe this one is the pipette I have, and I already took the solution into this pipette. Maybe this one is my pipette, and I fill solution here, and I know this one is 5 milliliter. Okay, and when I take the solution, I put into the container, so maybe outside I also have some solution here. If you don't clean with the tissue paper, so you have some droplet of the chemical here. So when you add it into another container, so this droplet can fall down, fall down. So it means that the total volume here will be more than 5 milliliter in your solution. So you should clean the liquid outside. And the second one, you should make sure that no purple inside, because if you have purple here, so it means that the volume of your solution also not 5 milliliter, less than 5 milliliter. Okay, and you try to adjust the liquid level when you use the pipette. Okay, and then when you add the liquid into another container, you should then put it look like 90 degrees to our container like this, because you put like this, the liquid go down, and liquid go down can move up like this, and it's dangerous, and also maybe you lost some chemical. Okay, so you should have the angle around 30 degrees. So you can see from here pipette here, and you make the wall of the container with the pipette around 30 degrees, and make it slowly go down, and all of the chemical can move to here. So you see from here, so this one also it is one. Okay, so this one is the basic one you use for the pipette, but actually in Some lab you also have the micropipette, and this one really expensive, and I think we don't use in our chemistry lab. Okay, but this one really easy to use, and you can take look like very small amount, maybe only 1 microliter, not milliliter, microliters. Okay, and the next one I consider about the burette. Okay, so the burette we will to use to measure the accurate volume as well. And for this one, we can get the higher accurate compared to our pipette. Okay, so from here, we usually use the burette for the titration. We want to measure the volume of the solution we use for some reaction. Titration you will study in chemistry later, and in chemistry lab we will do the experiment for titration later as well. Okay, so what we have from here? So from here we have look like also one column, right? But this one we need something to hand our burette. We cannot keep by our hand, okay? And we have the stop cock here. It means that we can lock our solution, okay? And when you lock here, even we also have some position here, right? But because you lock here, no air can be enter inside. So it means that you also can keep the liquid inside here. This one we call this one the tip of the burette, okay? So for burette here, you also have the volume marking. It means that they show you about the number 50, 40, 20, 20, and something, okay? But you see, different with the pipette, right? Or maybe some other. Because if you have the beaker, so this one will be 50, right? And the next one will be 40, and you have the higher position, you have the larger value, okay? And also similar for the pipette, but for the burette, you have different here. This one they have 0 at the highest position. Because for the burette, we will release the solution out. When we release the solution out, so we will read the value. So at the beginning, we may have 0. And then you release some solution out, maybe you get until number 10. So it means that the total volume here will be 10 milliliter. Okay, so you see a little bit different. Okay, and you also similar, you also can check for the liquid level. And from this liquid level, you should move your eyes to this position to read the liquid level. Okay, and for the pipette, we need to add first, sorry, this one not pipette, this one is the burette. For the burette, at first we will add the solution into the burette. So how to add the solution? Okay, so you can use the beaker. Okay, I may draw the beaker here, right? So we have the beaker, we have the solution inside, and then you add the solution into this one. Okay, at first you lock this one, and then the solution can fill in until here, and then you move this beaker to put here because you want to get the solution again. Okay, and when you get the solution again, so it means that you open this. When you open this, so the solution can go down, and go down, it can remove air out. So make sure that no air in this area, no air in your pipette, your burette as well. Okay, and when the air go down already, and then you also do something similar with the pipette, right? Because we shouldn't let the liquid stay outside of the tip here, because outside the tip it also can come to your container. So you clean the liquid around here, so it means that you clean everything around here. So now you have only the liquid inside here, only no bubble and liquid fill in all of the burette. Okay, and then you can add more until level 0, or maybe you also can use level 5 at the beginning. It's okay, because we want to know initial and final level, and then you will know how much for the volume from here. Okay, and then for your using, and then you just open this, and then the liquid can go down, and you have the final level, and then you can read the value from here to here. Okay, so no need to make sure at 0, it depends on you, and then just make the initial and the final level only, and then you can know the volume you use. Okay, so for here you can see we add the liquid into the burette, and then we remove the bubble at the tip, as I already mentioned, right? And then you clean outside the tip, and then you can adjust the liquid level. And for your using, I already know, I already showed you, right? But in the burette, we may have the dash volume. So what is the dash volume? Because from here to here, you can read the value, right? 23, and then the liquid maybe move to here, you have 24. So it means that you have 1 milliliter. Okay, or maybe it come to here, you have another 0.5 milliliter. But when the liquid come to here, and later for this part, we cannot measure. Okay, so this one we call that volume. You cannot use this one. Okay, and when we read the value for our burette, also similar. Okay, so you should move your eyes at the same level with the liquid. So when you read here, you should move your eye to here. When you read here, you should move your eye to here. You read the value, okay? And you already know about something to use to measure for the volume, okay? And when we use your um, the maybe some, that's what we call, that's one is some equipment or something, right? Okay. And after using, you also need to wash it, right? And after you wash it, maybe you have some water, okay? And with this water, how to remove the water? For the water, you need to you may put it into the oven, because when you put into oven and then we have the high temperatures. Maybe usually we use 70 degrees C or maybe 100 degrees C, and then you can remove the water. Okay, but remember, we cannot use oven to dry the pipette and the burette. Why we cannot use the oven? Because if you use oven, it means that we provide the heat, and when you provide the heat, it means that our glass can expand the volume, and then when we make it become room temperatures, it will reduce the volume again, and later expand and then come back to original volume, and then it may have some error for your measurement. Remember, for pipette and burette, we cannot put in the oven. So if you wash it and we want to use immediately, how to use? We can use the solution you want to measure and wash the pipette and the burette before using. Maybe at first I may wash it, right? I wash it with the water, so maybe inside with some water. And now I want to measure maybe 1 m HCl. So I just use 1 m HCl to wash this. And when I wash this, it means that I release everything inside with 1 m HCl. I may wash twice, and after twice washing, and then 2 times washing, right? And then you can see inside we don't have anything, any water only, right? Now we have this solution, and later we can fill this solution for your measurement, and you can get the correct value, okay? And for oven, they may have for the with or without vacuum, they can make a vacuum for the oven for some application, because in some condition you don't want to have air for your try, because you try and you have air, maybe you have some reaction with your material, yeah, and you can control the temperatures as well. Okay, so this one oven, you come to the left, you can see this one, and you have the beaker or you have some other bottle you can put into oven to make it dry faster, and you can use, okay? And we also have some other thing we call, this one is the Erlenmeyer flask, and we can use this one for reaction or titration. This means that we want to have some reaction inside, or maybe titration. I will show you what's the titration later, and we will use this one. So this one we also don't use to measure the volume, because you see the surface area really high from here. Just show you the level, because you can estimate the volume in your solution. You can use or not in some condition, okay? And when you add the chemical inside, and then you can rotate to mix the solution. So it means that you use your hand to keep the neck of this flask, and you rotate like this, and then the solution inside can mix well, okay? For titration also, okay? And the next one I talk about the test tube and the rack and the clip, okay? So we can use for some reaction. We observe the phenomena. So it means that we just want to add something inside, and we want to see what happens. We use the test tip, okay? Test tip will be something like this, okay? But this one, it cannot stand by itself, so we need to use the rack to keep it, okay? And sometimes we want to see some phenomena, or we want to take some picture, something like that. But you cannot use your hand only, because maybe some toxic chemical, so we need to use some clip. So clip here can help you to keep the tip, okay? And then you can take the photo, or you also can see some phenomena, okay? And the next one, we have the specific bottle we use to measure the density. So how to measure the density? You know that density equal to the mass divided for the volume. If you know the volume, you know the mass, and you know the density. And how to measure for the volume and the mass? If you have this cap bottle, right? And then you just add, because this one we have the certain volume here, so it means that this bottle 25 milliliter, if you fill all with the liquid, okay? And then you add the liquid, maybe add, this is the cap, and at the beginning you remove the cap and you add the liquid until here, and then you put the cap back, and when you put the cap back, and the cap we have the hole here. So when we put back, and some water can move out by this, or maybe it can move up to this position, and move to this position, because we can keep the level of liquid until here, okay? So it means that we get exact 25 milliliter, and we get exact 25 milliliter, and then we measure the mass of this bottle before and after adding the solution. We know the mass of our solution, and then you can calculate for the density. Okay, so we fill with the water, and remember, no bubble inside also. Okay, and outside should be no water, because when you put the cap back, you may have some water outside. You should clean, and also you don't use your hand only, because if you use your hand, maybe you have something attached to our bottle, and then also can affect to the mass of your bottle. Okay, or you also have the vial bottle in the lab. So we used to store the sample. We may put some chemical inside to keep it, or maybe you want to use for the reaction, something like that. Okay, and you also can use this one to weigh the sample, right? To weigh the sample. So it means that you can put this one into the balance, and then you add the chemical inside, and you know how much chemical, right? But remember, when you put this one, and you should press tar to make it become zero, and then you can add the chemical, and you know the mass of the chemical only. Okay. And we also have the funnel. For the funnel, it means that we can add the solution into the small neck bottle, or we add into the Birec. Because you see that maybe we have the bottle very small neck like this. Okay. So for this cap bottle, if you add the chemical directly, difficult, but you use this one and you can connect to here, and then it's easy for you to do this. Okay. Or maybe when you add the chemical, the solution into the Birec, and then you also can use this one easy. But remember, you should remove it before using the Birec for titration or for something, because if you don't remove this one, maybe some chemical, some liquid stay here, and later it can drop down and it can affect to your result. And when you fill the liquid into the Birec, so remember, you should wait until all of the liquid go down, because at the beginning you start, maybe you have some liquid at the wall of your Birec, so later it can go down, and then the volume will be changed. So for this kind of experiment, you need to make everything carefully. Okay. And we also can use this one for filtration. Filtration is mean that you put the filter paper here. If you put the filter paper and you add the solution, right? You may have the solid and you may have the liquid in your solution. So for the filter paper, we have the bore, and the solid cannot go through, pass through. So the liquid can go down, but the solid can stay at this position. We call this one a filtration as well. Okay. But this one we need to wait for maybe for a long time. It depends, because if you had a big particle, so it means that the liquid can go down easy. But if you have very small particle, it may lock the filter bore, the bore from here, and then it takes a lot of time, the long time. Then later I will show you another one. We call this one the vacuum filtration. It will make the process faster. Okay. And the next one we have the proper I mentioned at the beginning, right? So proper is mean that you can press here, and then you put into the container, and when you put into container, and then you let the air look like, at first you press here, right? And then you make it release slowly, and then the air move up, so liquid can move up, and you can have the solution in here. And then you want to add into another container, so you can press this one slowly, and it can rub by rub. Okay. So in the lab we may have this one, but usually we use this one because this one plastic one, we don't need to wash it, don't need to reuse, but this one you need to reuse. Okay. And remember, when you add the solution, the tip of the dropper shouldn't touch the container. So it means that you should add like this way. You don't put the tip here, connect to the container or maybe the solution, because something can attack to here, and then it's not good, because maybe we don't want to have later we will use this one again for the same solution, right? Maybe this one solution A, this one solution B. So if you touch to here and later you put back to solution A, it means that you have some B come to A. It's not good for your experiment as well. Okay. And we also have something with experiment with the temperature. So we want to measure the temperature, and for the temperature measurement, we have the thermometer. Thermometer is mean that we can, I think everyone know about this one already, right? So we have two kind of thermometer. The first one we use the alcohol, the second one we use the mercury. Okay. So for alcohol, you can see from here, we have the red color. Okay, you know what is alcohol, right? And for mercury we have this color. Okay, this one usually we measure around 100 degrees C or maybe 200 degrees C, and this one you can measure maybe with the higher temperature. Okay, for mercury, because just the change of the temperatures, and then the volume of the solution inside change, and it can move up, move down, and you know the value of the temperature, you can read the level from here. Okay. And also usually for the mercury one, you can get the more accurate value, okay? But when you use this one carefully, because mercury is really toxic, so don't wreck this one in the lab. This one, you also shouldn't wreck it, but if something happen, this one's still okay, but this one we need to make some treatment with the mercury. Mercury really difficult to collect it, because mercury, when you break it and mercury come, not only one drop like this, it can separate become very small drop and really difficult. You cannot collect it easy, because when you try to collect it, it may separate become smaller particle and it's really toxic. Okay, so when you work with this one, check it carefully and don't crack it in the lab. Okay, and the next one we consider about the glass stick. Okay, glass stick, not chopstick. Okay, so chopstick you may use with the bamboo, right? And this one we use the glass stick. We use the glass. Why we use the glass? Because this one we don't have reaction with our chemical, right? If you use a chopstick to stir the solution, it means that it can absorb some chemical or maybe some reaction there, right? And if you want to mix the solution, so you can use this one to stir. Okay, or we also have some stirring bar to mix our mixture. And for the stirring bar, we use the magnetic stirring bar. This one magnetic stirring bar. You put inside here, and you have some equipment like this. And if you turn on this one, and you have the magnetic field, can make this one rotate. When this one rotate, it can stir your solution, and you don't need to use your hand. You just let it there. Maybe for some solution, you take long time, and you can use this one. And after using, you need to use some magnet to collect the the stirring bar from your solution as well. Okay, and we also have the spoon in the lab, so you can see we had a stick, not chopstick, right? And we also had the spoon, and this spoon we use for chemical. Okay, so we just use for taking chemical, and remember to wash before and after using. Why we need to wash before using? Because maybe someone they use and they didn't wash it carefully. Okay, so you need to wash it, make sure it's clean, and after using you need to wash it to return it. Okay, we may have this cup spoon, or maybe this cup spoon, or maybe this cup spoon. We may have the metal one, or maybe the elastic one. It depends. Okay, and we also have the thermostatic water bath. It means that you can control the temperature for your reaction. So you can set the temperature here, and then the water inside will be at this temperature for your reaction. Maybe you want to have reaction at maybe 40 degrees C, but room temperature maybe with air conditioner, so we have only 25 or 30 degrees C, and it can move up, down, and unstable. But this one you can get the stable temperature for your reaction. Okay. Or you don't have this one, you also can make something like this. You need the hot plate. Hot plate means that the one you can hit. Okay. And you also use the box, or maybe here I put the beaker here. And the beaker here, so I have another sensor. This is the sensor, the temperature sensor. It means that we can control the temperature. So I can set the temperature here. If I set, because it look not really clear, right? So maybe here or here. I think this position, right? If you set the temperature here, so then the hot plate can heat your solution until this temperature, and it can turn off heating. And then if the temperature go down and it can turn on heating, it means that automatic, and you can control the temperature of your solution inside. Look like similar with this one. Okay. And we may use, actually this is the beaker, but usually we use the box. The box we can add the water, right? Maybe the box like this, we are on the surface of the hot plate. This is the hot plate. Okay, and we use the box. Okay, this one not a hot box, right? This one just a box for your experiment. So you can add some water or oil. It depends on the experiment you want. If you want the temperature maybe less than 100 degrees C, or 100 degrees C boiling point of temperature of water, so you can use the water to add to here. But if you want to use 500 degrees C, maybe you should use some oil, because for water 500 degrees C we cannot get that temperature, right? Because boiling point 100 degrees C. Okay, you need to find something with the boiling point higher than this temperature. Okay, and after you have this one, and you can put maybe your container for the chemical reaction inside here. Okay, and then you can control the temperature. Okay, and the next one we may consider about the separatory funnel. So this one we use to separate the insoluble mixture in the liquid phase. We usually use for extraction, because for this one you can see if you have the water and maybe you have the cooking oil or olive oil, and then insoluble, so oil lighter on the surface and on the top, right, and water at the bottom, and then you can open this and the water can go down until here. This level come to here and you stop it, and then you can separate two level, right? And you also can make some extraction. Look like at the beginning you have something inside and you want to, because maybe this one you have the organic phase, and this one you have maybe water phase, and something can dissolve in water but not dissolve in not dissolve well in this phase, and then later you can add more water, and later you can remove some compound from here to here, or maybe from here to here, because I think for this project they remove from here to here because the pink color move off. Okay, so we have two different phase, and this one you will stay in chemistry lab 2. I just want to make the introduction about this equipment in our course here only. Okay. And the next one I consider about the vacuum filtration. So it means that we can separate the solid and the liquid. I mentioned already, right? So for funnel, you already know funnel, and then you can make the filtration, but not strong enough because you just let the liquid go down, but it may lock here. So for this cap system, you come to lab, you can see this one. You use the pump, and the pump can remove air from here to here. And then when we remove air, so it means that we have the force, and we let the liquid go down faster. Okay, and we may use the air pump, or maybe for the water pump we use this one. We just want to take air, okay, remove air inside, and when we rest, air come to this direction, and then this one direction, and then we can go down easier. Okay, and we also need to put the filter paper at this funnel. Okay, and then we can collect for the solid one. Okay, and we also have some other thing look like the watch glass. For the watch glass, it means that we want to see some phenomena on the surface, but we don't put a lot of the chemical or something like that. Okay, and tissue paper, and this one not really the normal tissue paper. Normal tissue paper you use at your home, so we have some dust, right? We may have some um, paper particle. Okay, it can release to your equipment. So this cap paper is quite expensive. I forgot the price. I think around 100 NTD for one box, or around, I'm not sure. Okay, so this one no dust, so this means that you can use to clean some equipment and you don't have any dust on the surface. If you use a normal tissue, you can have any dust, some dust on the surface, and it's not good for your experiment. Okay, and we also use the sandpaper. I think you also know what is the sandpaper, right? So we have the rough surface here, and then you can clean the metal surface when in your experiment. And we also have the aluminum foil, and this one we just use it to cover the sample, or maybe for the water bath. Okay, and when you do experiment, you also consider about your garbage. Okay, for the garbage, we have two kind of garbage in the lab, one with the chemical, one without the chemical. So if you have some garbage with the chemical, you can put here because we need some treatment. Okay, and the one without chemical, so you can you can put anywhere. Okay, so you shouldn't put in here, because if you put in here, we need to spend money for this treatment. Okay, so don't take the food or the drink or something look like the normal trash, look like the paper or your tissue paper you want to clean your face, something like that. Don't put into the one for the chemical one. Okay, so we should separate for the chemical and non-chemical. And for the chemical waste container, because for some experiment we use some normal chemical you can pour into the sink. Okay, but for the toxic chemical we need the treatment, we cannot pour into the sink. Okay, we should protect our environment, so we should put in some specific container. And for specific container here, so in the lab we may I will add the TA to prepare maybe some beaker for you, and you may add that one inside, and later add the when we finish the class, and we can put together into this one, because we don't have only one kind of bottle, we may have different kind of bottle, maybe for the heavy metal, or maybe for some this kind of ion will be maybe together in one container, and if you have look like the heavy metal or something like this will be for another container. So we have different for the treatment as well, you cannot mix together. Okay, and the next part I consider about some chemical. Okay, so this chemical, and you can see first, and later when you come to the lab, easier for you to recognize the chemical. Okay, DI water. So when you do experiment in the lab and you cannot use any water, or maybe the water for washing your hand, or maybe for taking shower or something, because you have something inside, right? At least you have some ion inside, and if you have ion inside and you do this reaction, and it can affect to your result. Okay, so we use the water, it means that the one where we remove ion, only water for your experiment only. Okay, and usually we keep in some bottle like this, and you can use this one for your experiment. Okay, and we also have the soap maybe for your for you to wash your hands, something, right? And also we have one experiment with the soap, you know what is the soap already. And we also have the tea tree essential oil, so this one also one kind of the essential oil. So you can use this one to add into the surf for the first experiment next week, okay? Or maybe you also can use this one at your home, right? Maybe you can use some instrument and let this one vaporize into air, and you have some good smell, good for your health, or maybe you sleep well, something like that. And we also have the dye, we also use for the shop only. So something really simple, okay? And we also use the commercial bovidone iodine. So we also have this one. I'm not sure everyone know about this one or not, but you can buy from some medical store, right? And for the wound treatment, something because it can kill bacteria. And we also use this one in our experiment, okay? Maybe for the starch solution, and this one we have some solution, but actually this one just look like the rice, okay? When you mix this and this together, you can get the dark blue color, something like that. And this one something around our life, okay? And we also have some other chemical look like for the CaCO3 with the white color. And this one is insoluble in water. When you put it to the water, it's still the solid in the water, okay? Or you may have the silver nitrate, and this one you can see we use the black bottle because this one sensitive with the light, okay? And the white powder, and when you dissolve in the water, it will become transparent solution, okay? Look like water, but you have silver nitrate inside, okay? And you also have the copper nitrate, right? So copper nitrate because actually for our salt, some salt we have only the salt, but some salt when we repair we have some water will bond, will bind to our salt, okay? So it depends on the structure. I mentioned in chapter 2, and you can check it in chemistry, okay? So we may have this one for the copper compound. We have this color, the blue color. When you dissolve in the water, you also can get similar color for the solution, okay, for the blue solution. And copper sulfate, so the reason because due to the copper 2 plus, we get this color, okay? Even you have NO3 minus or you have SO4 2 minus, but you have the same color, okay? And this one you have the PaNO3 2, and this one the white color with the powder, but you dissolve become transparent as well. And this one is the copper, right? You know what's the copper? We also do experiment in our chemistry lab, okay? The next one, we have acid HCl or maybe NaOH. So you can see here, colorless. You see, colorless, but actually it's really toxic, right? So it's dangerous, not really toxic, but it's dangerous, okay? With the high concentration. So actually this one is the low concentration in your top match. We also have HCl inside, okay? And HCl, this one the gas, and then they can dissolve in water to get the concentrated HCl solution. And for your using, you may dilute with water to get the low concentration. In your top match, you had a low concentration, it's okay, but the high concentration can damage your look like the tissue cell, something, your skin, okay? On average, that's the solid. And when you dissolve in water, you can get the transparent solution like this, okay? And we had the phenolphthalein. For phenolphthalein, you can use, that's the indicator. In acid, colorless. In basic solution, it become pink color. So you add to here or to here, you can know that's the acid or maybe basic solution, okay? Or we also have H2SO4. This is strong acid, really dangerous. So when you work with this acid, should be carefully, okay? And this one can uptake a lot of water, so it's really dangerous. If this acid concentrated one can attack to your skin, and then it can uptake the water from your skin, so your skin will be really terrible, okay? Or we may have some other acid. This one we have the oleic acid. So this one just look like the fatty acid you can get maybe from the oil, some oil or something like that. You can get this kind of the acid. You see acid, this one nothing happen, it's really safe, something, right? Friendly, yeah. But this one in your top match you have, but low concentration, high concentration, dangerous. And this one really dangerous, okay? Sulfur, this one just look like one kind of element we have. And when we come to the lab, if something happen with the mercury for the thermometer, so if you have mercury, so you should use the sulfur to collect mercury, because mercury it will be the particle like this, right? And then when you add the sulfur, and sulfur can collect this one, and easy for you to collect, and you can solve the problem, okay? Or you may have MnSO4, this color, but when you dissolve in the water, you can get a transparent. And this one we have KMnO4. You can see a little bit different, right? Also and sorry, this one we have oxygen and sulfur, but this one we have MnO and potassium, and then you have this color, okay? Or maybe you have this with this color, you have K, you can see K, right? But Ki, we have the white color, dissolved in water, transparent. And this one you have orange color, this one we have the yellow color. So you can see just a little bit different, and we have the different for the properties. This one we call physical properties, right? The color, okay? And also we have NaCl. So we have the white color and dissolved in water, you can get a transparent solution. This one also. And this one we have the baking soda, right? Or this is the name or chemical here. You can see white color. And then when you dissolve in water, become transparent solution. H2O2, someone know about this one, right? Okay. So you can check this one. I already talked in the class of chemistry, right? So this one is molecular compound. So you keep two here. We don't make it become one. Active carbon. So this one can absorb a lot of toxic. So usually we want to absorb some toxic material. So that's the reason why when you do experiment, we ask you to wear the active carbon mask because it can absorb the chemical into the carbon here, can protect you, okay? And for the agar is mean that the one you make the jelly, right? You know agar, right? You just dissolve it in the water and then you cook it and then you let it cool down to temperature. You can get some jelly like this, and this one we call this one agar, okay? And we may have some solvent, organic solvent, not all, but usually organic solvent is toxic one, okay? So when you work with this one, should be carefully, okay? For this one, I think it's okay because you can use this one to clean the pen on your nail, okay? So acetone. This one we have the toluene or we may have the methanol, so some other one, and this one dangerous, so be careful when you use this one, okay? This one also not really friendly. Even you have ethanol. Ethanol is mean that the one you use to clean your hand, to kill bacteria, or even in the alcohol you can drink, okay, in the maybe in the beer or maybe in the liquor, but this one no, this one is not we cannot drink, and it's also toxic, okay. Or we may have FeCl2, you see this color, but FeCl3 we have another color, okay. So you can see just a little bit different, and you can have the different for the color. And actually this one we don't care too much because this one just depend on the properties, and we have some water accompany with this one, because you know if we actually also can prepare this chemical, but when you prepare this chemical and you sell to some people, and when you sell to the people, and then water can absorb and also can change become this one, okay. So usually when you buy the chemical, they will sell you this or this, okay. And this one you have the MgO something, okay. And you also have this solution, and this one the smell not good, right? So I think you know what's in this one, okay. You go to the restroom, you can feel this smell. Maybe it depends. Maybe the restroom is really clean and you cannot feel it, right? Okay. So this one is ammonium hydroxide, and this one we have the salt of this one, white color. But when you dissolve in water, become transparent. Okay. This one also, when you dissolve water, transparent. This one also. And this one, when you dissolve water, you have this color. And you can see the difference here with water and without water, and we have the different color. So when you dissolve this one water, you get the same solution with this color. Okay. But when you use this solution and you draw something, maybe I use this solution, I draw something like this, and at the beginning I have this color. But when I let it dry, water can be removed, and when water removed, I can get the blue color or some color like this. Okay. And the last part, when you do experiment, you should check what you have at the beginning. And then when you finish, you need to clean everything and put it back and make sure everything is the same at the beginning. Oh, and I don't mean about the chemical. I mean about the equipment or something, okay? And then you need to clean your lab, okay? So for the desk, you can use the towel, okay? Something like this in the lab you can use and you clean, okay? So you should wear the glove because on the desk, maybe someone, uh, when we do experiment, maybe some chemical there. So carefully. And for the wave chemical, we should separate for the toxic and non-toxic one. Look like for the dye or maybe for some NaCl solution, something like that, and you can pour into the sink. But some toxic one, the TA will let you know, and you should collect the chemical, and then we put it into some specific container for the treatment. And we need actually not we, okay, for the department, they need to pay the money for this treatment, okay. And for the apparatus, and after using, you should wash with the soap and water. Okay, water at the sink, the normal water. But after finish this one, you should use the ice water to wash again. Because if you have the container here and then you just wash with soap and normal water, so maybe some iron can can be here. And later when you do experiment for the next experiment, and then you add the ice water, but actually not the ice water anymore, you have iron there. So after finish washing, you need to add some the ice water to wash again to remove iron. So it means that inside should be nothing. You can use something like this in the lab to wash it. Okay, and we need to do the quiz. The quiz, I send you the link, and then you can submit the quiz. Okay, so for that one we have 80% for the quiz from the link. Okay, and you also need to submit to me another report for this one. Okay, very simple. You just try to raw some equipment in the lab, but not separately. You should, because you already check my video or maybe for my material, and you know the purpose of each equipment, right? Okay, and so for the purpose of each equipment, and you can see we can make the combination, right? Look like for beaker, you keep the solution and then you can pour the solution into the Birec. But before come to the Birec, you can put the funnel, okay? And you let the solution go easier, and then it can come to the Birec. And after it can come to the Birec, and then you take the titration, so you put another flask here, and then you can make some titration. It means that we combine together in one process. So as first I add the chemical into here, I need this one, and I can get the chemical into this Birec, and after get this Birec, and then I can use this one for titration. So it means that the process here for my titration. Okay, so for titration I use 1, 2, 3, and 4 for equipment. Okay, so the report you need to raw equipment. This one I don't I didn't I don't have enough time to raw it. Okay, so I just combine the equipment together. But for you, you need to raw. Okay, you can combine any equipment together in one project, not separate equipment. Should be one project like this together. Okay, so you should use at least I think at least three. Okay, no, I think because you have 20%, right? Okay, 20%. So I think you should try at least four equipment together. Look like this is 1, 2, 3, 4 in one project. Okay, and you can submit this one to me on Monday. Okay. Okay, so that's all for this introduction. Okay, not really simple, but you should learn, and then you come to the lab, you can make it better.